Let's explore SQL Injection Prevention. This presentation will guide you through securing your applications against database attacks. So, what exactly is SQL injection? SQL injection is a code injection technique where malicious SQL statements are inserted into user input fields. These statements are then executed by the database, potentially granting unauthorized access to your data. Here is an example of vulnerable code. First, a user ID is retrieved from a request parameter. Then, a query is constructed by directly concatenating strings. Now, a malicious user could input a string like single quote or single quote 1 single quote equals single quote 1. This would result in the following SQL query. Select asterisk from users where ID equals single quote or single quote 1 single quote equals single quote 1 single quote, which would return all users from the table. There are different types of SQL injection attacks. The first one is inbound, also known as classic SQL injection. This is the most common type. Attackers use the same communication channel for both injecting the malicious code and receiving the results. This includes error-based techniques, where the attacker relies on error messages from the database to gain information, and union-based techniques, where the attacker appends a union select statement to retrieve additional data. Next, we have blind SQL injection, also known as inference SQL injection. This occurs when direct results aren't visible to the attacker. Instead, they must infer the database structure by sending payloads that trigger conditional responses or time delays. For example, they might construct queries that cause the database to pause for a certain period if a condition is met. Finally, we have out-of-band SQL injection. This is used when attackers cannot use the same channel for both injection and retrieving data. It involves making the database server communicate with an attacker-controlled server, often by using features like database links or external procedures. SQL injection attacks can have significant repercussions for both the technical infrastructure and the business itself. On the technical side, SQL injection can lead to unauthorized access to sensitive data, allowing attackers to steal confidential information. It can also result in database manipulation or even destruction, causing data loss and system downtime. Furthermore, successful attacks can compromise back-end systems and, in severe cases, lead to a complete server takeover. Finally, attackers can extract and exfiltrate large amounts of data, leading to further damage. On the business side, the consequences include regulatory fines and penalties for failing to protect sensitive data. Data breaches can result in legal liability and lawsuits. The attacks also damage the brand's reputation, leading to customer trust erosion. Ultimately, SQL injection attacks can cause financial losses from operational disruption and recovery efforts. Let's explore how to prevent SQL injection, starting with prepared statements. Prepared statements, also known as parameterized queries, separate the SQL code from the data. This forces the developer to first define all the SQL code with placeholders, and then pass in each parameter to the query separately. This approach ensures that user inputs are treated strictly as parameter values, and not as part of the SQL syntax, effectively neutralizing injection attempts. Here is an example. The top code block shows unsafe direct string concatenation to build a SQL query. The bottom code block shows how to use prepared statements. The query is defined with a question mark as a placeholder for the username. Then, a prepared statement object is created. The username is set as the first parameter in the statement. Finally, the query is executed. Another prevention strategy is to use object relational mapping, or ORM frameworks. ORM frameworks abstract database interactions by mapping database tables to code objects, handling SQL generation and parameterization automatically. These frameworks reduce the amount of direct SQL writing required, and they use safe parameterization internally. Some examples of ORM frameworks are Hibernate, Entity Framework, Django ORM, and SQLize. Here is an example. The top code block shows raw SQL, which is risky if not parameterized correctly. The bottom code block shows how to use the SQLize ORM to find a user by username, which handles parameterization safely. A key strategy in preventing SQL injection is input validation and sanitization. Input validation means verifying that user input conforms to expected formats before processing it. There are several types of input validation. One is whitelist validation, where you allow only known good input patterns. Another is type checking, where you ensure inputs match the expected data types. Lastly, we have range checking, where you verify numeric values fall within the allowed ranges. For example, if an ID must be a positive integer, you can validate that the input is both numeric and within the acceptable range. Here's a Java validation example using regular expressions to validate a user ID input, and a JavaScript example to validate a product ID. Stored procedures are SQL code that is stored and executed on the database server. They allow parameterized access to database operations without exposing SQL directly. Stored procedures offer several advantages. A precompiled execution plan improves performance. It also encapsulates business logic at the database level. Parameters are handled securely by the database engine. It also reduces the privileges needed by application accounts. Here is an example of creating a stored procedure in SQL Server to get a user by username, and then calling the stored procedure from Java using a callable statement. When it comes to SQL injection prevention, a defense-in-depth approach is the best way to go. The first layer of defense is input validation. This involves validating all user inputs against strict whitelists and expected formats before processing. The next layer is parameterized queries. Always use prepared statements or ORM frameworks to separate SQL code from data inputs. Next, apply the principle of least privilege for database accounts. Use database accounts with minimal permissions required for the specific application functions. The final layer is monitoring and web application firewalls. Implement web application firewalls and active monitoring to detect and block suspicious queries. Here's a quick summary of the best practices for SQL injection prevention. Always use prepared statements with parameterized queries. Implement strict input validation and sanitization. Apply the principle of least privilege for database accounts. Use ORM frameworks when possible to abstract SQL generation. Implement error handling that doesn't expose database information, and conduct regular security testing and code reviews. There are also additional resources to help you learn more. These include the OWASP SQL Injection Prevention Cheat Sheet, NIST Database Security Guidelines, Portswigger Web Security Academy, database-specific security guides, and automated security testing tools like SQL Map and OWASP Zap. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.